In this section, we are now going to consider what you do if you have an improper fraction. That's when the degree of the numerator is either greater than or equal to the degree of the denominator. So we call that an improper algebraic fraction. These need algebraic division before we can split them into partial fractions. And by the end of this little section, you should be able to split an improper fraction into partial fractions. Our example is taken from a past paper question. It's expressed this in partial fractions. Now, the most common mistake in this question would be to not check whether we have a proper fraction. So the most common mistake, and please don't do this, is to look at this and go straight into partial fractions, something over x plus 2 and something over 3x take 1. You will never get the right answer, and you probably won't get any marks whatsoever on this question. So train yourself to always look when you're doing partial fractions and ask yourself, do we have a proper fraction? Well, in this case, no, we don't. We have an improper partial fraction. The degree of the numerator is 2 and the degree of the denominator is also 2. If you imagine expanding the brackets in the denominator, the highest power of x would be 2. So we need to use what we learned in a previous section. Something quadratic divided by something quadratic gives us a constant term plus something linear over the same quadratic that you were dividing by previously. So using that, we can turn our improper fraction into a constant term plus a proper fraction. We don't know what the numerator is going to be yet, so I've just called it lowercase a x plus lowercase b. I've used lowercase a and b because in my solution I want to use capital A and capital B like I've done in all my previous ones. Now there is an alternative there. You could also use algebraic long division if you prefer that, and if you did that you would get values for my lowercase a and lowercase b. We're no better off doing that method. We don't actually need to know those values, because what I'm going to do next is split this apart into partial fractions. It is a proper fraction, so that means we can now do that. Checking the denominator for repeated factors, but we don't have any, so that means our fraction that we started with is going to be a constant term, don't forget this constant term, plus something over x plus 2 plus something over 3x take 1. I've used capital A, capital B, capital C for my unknown constants. From here, it's just the same process as before. So I recommend you pause the video and try and now get to the final answer. I'm going to do my solution in 5 seconds time. I've combined the fractions on the right hand side, given them all the same denominator that the left hand side has, and now conclude that the numerators must be the same. I've said this in previous examples, but here it is again. With enough practice, you will be able to go straight from line 1 to my line 3 here. Now I'm going to actually compare coefficients of x squared first. The order you find A, B and C doesn't matter. In previous examples I've compared coefficients last. This time I'm going to do it first. So on the left hand side we have an x squared term of 9, and then you've got to imagine expanding the right hand side. Well, x times 3x will give me an x squared term. It'll actually be 3 lots of x squared. I won't get any in the b term, and I won't get any in the c term either. So by comparing, I can say 9 must equal 3 lots of a. Because expanding this, we'd get a times 3x squared. So 3 lots of a must equal 9. That's given me a. I could continue comparing coefficients to find b and c, but I'm not going to. I'm going to let x equal minus 2. This is called substitution, because that will make this bracket 0 and this bracket 0, meaning I'll be able to find b. I'm now going to let x equal 1/3, because that will make this bracket 0 and this bracket 0, allowing me to find c. Now be careful subbing this in. Of course, you will have a calculator in the exam, but it might be a good idea to try and do it without your calculator first, to make sure your mental arithmetic or your just written arithmetic skills are strong. In the end, we find c is -1. Don't forget to write down the answer, and any rearrangement of these 3 terms will be correct. So if you tried to do this question before me and you had different letters on top of the fractions, just look at your final answer. If it's the same as mine, then well done.